Hi, welcome to the second part of our lecture dedicated to banking. In this part we are going to have a look at money creation, the astonishing feature of a banking system. As you may remember, this whole fractional reserve banking, which is actually the essence of modern banking activities, had three features. We distinguished three features here: of profitability of bank money creation, and exposure to runs. The first and the third feature were thoroughly explained in the previous part of our lecture, so bank money creation is what we want to deal with now. What is this money creation about? It is simply the idea that banks can lend more money than they have deposited in the vaults. That might be a bit surprising if you remember what was this fractional reserve banking about. So you gather 1 million of deposits, you keep a certain part of those deposits as a reserve, and the rest is given as a loan. So that would suggest that banks can give a loan of the value that is smaller than their deposits. In this way, banks would be worse than you, because if you have 1,000 zloty, then how much you can lend to other people? Well, if you have 1,000, you can lend 1,000. With banks that are obliged to keep some reserve, 1 million of deposits would not apparently allow them to loan more than 1 million or even 1 million. They would be able to lend less. Yet they are able to lend more. How is it done? To understand that, let's take three assumptions. They will simplify the whole process, but actually we will try to remove them later on. So the first assumption is there is just one bank in the country. Not one building, but imagine that all branches or offices are owned by one single bank. This is a simplification. In fact, we've got one banking system. So the money goes into one banking system instead of one bank. But I believe it is easier to understand the whole process if you imagine there is just one bank. Remember, this money creation is not performed by a single bank. Actually, it is performed by the whole banking system, but we have just one banking system, like in our assumption there is just one bank in the country. The demand for loans is unlimited, so if there is any money that can be lent, then there is immediately someone who would like to borrow this money. This is not very true. I mean, this is not very realistic, but it will be very useful for our model of money creation, and we will have a short look at what would happen if this assumption is not true. And the third assumption that we make, no one takes a loan in cash. As you know, there are two types of loans you can get from a bank: a cash loan, where banks simply give you some cash, or a non-cash loan. So at first, in our first step, we will assume this assumption: no one takes a loan in cash, which means there are no cash loans in the system. That allows us to move to simple money creation. So let's assume there is a certain required reserve ratio. Let it be 20% in our case. Again, it's not very realistic, it's very high. When you look at Polish banking system, the required reserve ratio is 3.5%. But 20% is a nice number for calculations, so let's stick to 20%. Let's imagine that our bank, remember we've got just one bank in the economy, our bank gets an initial deposit of 100,000 Polish zlotys. Someone comes with this kind of money and makes a deposit, and here we are at phase 1 when there is a deposit of 100,000 and we are obliged as a bank to create the reserve. The required reserve ratio is 20%, so 20% out of our deposit is 20,000. So we've got a deposit of 100,000, we've made a required reserve of 20,000, and that leaves us with 80,000 that we can actually give as a loan. And following our assumption number 2, if there is money that can be lent, there is someone willing to borrow it, so there is someone who comes to our bank and wants to get a loan of 80,000. Remember, there are no cash loans, therefore the money that someone wants to borrow will be transferred to someone else's bank account. So for instance, someone comes, wants a loan, wants to buy a car for 80,000, so this 80,000 will be transferred to the bank account of the car dealer, and the car dealer will give the car to our customer because the car dealer feels he is paid. The money of 80,000 are deposited in their bank account. We started phase 2. There is a deposit of 80,000 on the, let's say, car dealer's bank account, and since there is such a deposit, we need as a bank to make a required reserve of 20%. 20% of 80,000 is 16,000. So we had a deposit of 80,000. We made a reserve of 16,000, and that allows us to make a loan of 64,000. So there comes someone who wants such a loan of 64,000 to buy something, whatever it is. And this 64,000 will be therefore transferred to the bank account of the seller. Whatever our customer wanted to buy, this money will be placed on the bank account of the seller. So the seller, is it a car dealer or someone else, doesn't matter. This money will be another deposit of 64,000, which requires a reserve to be made. So we make a required reserve of 20%. 20% of 64,000 is 12,800, which leaves us with 51,200 of money that can be given as a loan. As you can see, this process can go on and on and on. And the question is, how many deposits can we create in this way? There are a few ways of answering this question. We can use logic. So first of all, let's try to trace the cash. The cash appears in two places in this table here. First, initial deposit of 100,000. It is made of cash. That was cash that was brought to the bank. Then the second place is required reserves. We make required reserves from cash because this is, remember, money that we keep in case someone wanted to get their money back. So we need to have cash. So how big could be the required reserves? Well, how much money, how much cash do we have? The only cash that we have in our table was this initial deposit of 100,000. Therefore, required reserves can be as big as 100,000. Now it all seems very simple. Required reserves are 5 times smaller than deposits. So if the required reserves are 100,000, then deposits would be 500,000. Deposit minus required reserve is a loan, like 100,000 minus 20,000 is 80,000, phase 1. So if the total deposits are 500, required reserves are 100,000, and loans would be 400,000. And this is how much loans can be given. As you can see from the initial deposit of 100,000 zloty, we are able to make loans of 400,000. The total value of deposits is 500,000. 100,000 was placed in the first phase by someone who brought cash. The rest, the remaining 400,000 of deposits, were simply created by the bank system. So you can find a formula for total deposits. That's initial deposit multiplied by 1 over the required reserve ratio. In our case, it is 1 over 20%, which is 5. This 1 over required reserve ratio is called money multiplier. It tells you how much of deposits can be created out of 1 zloty or $1 of initial deposit. This formula is based on the idea of infinite geometric string, so you can actually use this mathematical knowledge to calculate what is the sum of deposits. See that each next deposit is created by multiplying the previous value of the deposit by 0.5. So this is 100,000 times 0.8 gives you 80,000 times 0.8, that gives you 64,000 times 0.8, it gives you 51,200, and so on and so forth. What if our assumption number 2 is not true? So what if demand for loans is unlimited? Then the whole money creation mechanism would stop. It can stop, for instance, after 3 phases, and then we would have just 3 deposits: 100,000, 80,000, and 64,000. So the money multiplier informs you about the maximum possibilities for money creation, not actual money creation, because this actual money creation would depend on to what extent people want to take loans. Each loan taken allows to create next deposit. So this is how money is created. What if our third assumption about the lack of cash loans is not true? We know that many loans are non-cash loans, like mortgage is never a cash loan, but people do take sometimes cash loans. So how would it change the situation? Let's move to complex money creation. Well, complex money creation acknowledges the fact that some of loans are taken in cash. In our example here, we assume that percentage of loans taken in cash is 25%. Our required reserve ratio is still 20%, but because of the fact that we allow for some loans to be taken in cash, our assumption number 3 would not be valid anymore. To make matters more simple, we just assume that each loan taken is partly taken in cash, like 20%, 25% in cash, and it is partly taken as a non-cash loan. Again, we've got our customer who makes the initial deposit of 100,000. So we create the required reserve of 20,000, and that allows us to make loans of 80,000. 3/4 of this amount will be taken as a non-cash loan, 60,000, and 20,000 would be a cash loan. According to our assumption, 25% of 80,000 of loans is taken as cash. If we proceed to phase number 2, then you are going to notice that the new deposit is actually created only from this non-cash loan. So it's 60,000 that appears in phase number 2 as a deposit. And this deposit requires from us to make a reserve. So this is 20% of 60,000, which is 12,000, and loans would be 48,000 with 36,000 of non-cash loan and 12,000 of cash loans. Again, only non-cash loan, like 36,000, will be the deposit in the third phase. Okay, so let's have a look, because those phases could go on and on and on infinitely, as you know. Let's stay here and let's have a look at how much of deposits and loans can be created and given here in this complex money creation situation. Again, we could use logics or we could use mathematics. For logics, we trace cash again. So we've got this initial deposit of 100,000, and we can locate cash in two other places of this table. This is required reserves. Remember, we make them in cash only. And cash loans would be the other place where this money in the form of cash appears. As you can see, the numbers that I decided to use, the required reserve ratio of 20% and percentage of loans taken in cash 25%, they make nice numbers. The required reserve in phase 1 is equal to the cash loan in the value. Like in the phase number 2, the required reserve again is equal to cash loans. So you could say this money goes equally to required reserves and cash loans. So if we've got 100,000 of cash as deposit, then required reserve and cash loans together can amount to this 100,000. So divided into 2, required reserves would be 50, cash loans would be 50,000. So that's how much required reserves and cash loans are. If we know the required reserves, we know that deposits are 5 times bigger. So if required reserves are 50,000, deposits would be 250. 250 deposits minus 50 of required reserves is 200,000 for loans, and those 200,000 for loans would be divided into 150, 3/4 for non-cash loans and 50 cash loans. You can see that the amount of deposits and the amount of loans is now considerably lower. If we allow cash loans, then some of the cash will leak out of the banking system, and the possibilities for creating reserves would be smaller. Therefore, the possibilities of making loans would also be smaller. You can also see this complicated formula that tells you what would be the value of total deposits depending on initial deposit and complex money multiplier that is based on required reserve ratio and the percentage of loans taken in cash. That's this C letter here. You can also see that if you use this formula and you take that percentage of loans taken in cash is 0, so C is 0, then this whole complicated formula reduces to well-known 1 over required reserve ratio, which was the simple money multiplier. What do we learn from this complex money creation? Banks do not like giving cash loans. And you can see it clearly because cash loans are usually considerably more expensive. I mean, banks usually charge a bigger interest rate on cash loans rather than non-cash loans. So this is a kind of a incentive for us to take rather non-cash loan rather than cash loan, because this is more costly for the bank. We have already discussed the supply of money, but now it's time to have another look at that. To what extent money supply can be controlled by the central bank? Obviously, part of it can be very directly controlled by the central bank. This is M0, this blue line at the bottom of the graph that you can see here. This is cash, and since cash is issued by central bank, the central bank can decide how big is M0. But then the supply of money is actually something bigger. M2 is considered to be supply of money, and this M2 is created on the basis of M0, but it is created by the banking system. As you already know, the possibilities for banks to create money depend on two things: percentage of loans taken in cash and demand for loans from the customers of banks. Additionally, obviously, this required reserve ratio plays some role here. So there are three elements here. With the required reserve ratio, that is fully controlled by the central bank. The percentage of loans taken in cash, which is more about what customers want, and banks can influence that by setting different interest rate for cash loans and non-cash loans. And demand for loans from the customers, and this is partly the matter of how costly those loans are. So that's the interest rate, and that could be to a great extent indirectly controlled by the central bank. But partly it depends on the situation in the economy, expectations, whether people want to take a loan, whether people want to consume more, whether people want to buy a house, so take the mortgage to finance that. So we could say actually only M0 is directly controlled by the central bank. Other parts of the money supply can be indirectly influenced by central bank, but they cannot be fully controlled. So if the central bank is to decide upon the supply of money, this task doesn't seem to be very simple, and we are going to discuss it in next lectures. Well, thank you very much for your attention. As always, if you like my lecture, leave a like or subscribe to the channel. Thank you very much for your attention. Bye.